speaker, which is Juan Pablo Zuluaga. And Juan will present us the paper on contextual semi-supervised learning, an approach to leverage air surveillance and untranscribed ATC data in ASR system.
Thank you. Hello, everyone. Thank you first for attending the session. Yeah, I'm going to talk about contextual semi-supervised learning. So by contextual, what I mean is how we can, contextual, I mean air surveillance data and how we can integrate this information during semi-supervised learning, not just when we want to test, let's say, the ASR system, but how to integrate that and train the system in a semi-supervised fashion. As main highlights here about ASR and in ATC air traffic control, our main motivation is that we know that adding ASR systems in ATM and ATC can increase safety and reliability and performance, which in turn can make less fuel consumption in airplanes in general terms. But the main problem or main challenges of ASR in ATC is that we know that it's not an easy task. Normally there is a lot of noise, for example, cockpit noise in the airplanes. There is also inter-speaker variations, as we saw in the previous presentation, accents, stress fatigue, and things like that. Also, on the other hand, we know that the data is very expensive to annotate. For instance, the real-time factor, some cases is 15, 20, or even more. That means that if you want to transcribe 1 minute of data, it takes around 20 minutes of human like annotation or time to annotate this minute, which, and in some cases, you need also special people with this knowledge, which make it very costly. So as a solution, we have come up with a pipeline to collect air surveillance data, what we call contextual knowledge, and interface. Also, we have developed a pipeline to interface this data in the ASR system, more specifically during ASR semi-supervised training. So in turn, we have leveraged contextual knowledge during semi-supervised learning, and also we come up with a ATC-based metric, which is the Callsign Word Error Rate, and it's the word error rate of the callsign in the utterance, which is a direct insights of how the ASR system is performing in the callsign. As we saw in the previous presentation, we don't need just the word error rates, but how the system is detecting or transcribing the most important, well, one of the most important parts in the communication. So ATCo 2 is financed by Clean Sky, and is also following similar projects like Aclista and Mallorca and Hawaii, which the idea is to push these ASR technologies and at some point implemented them in the ATM or ATC environment. So the proposed pipeline, this is an overall picture of what we have been working on. So on the one hand, we have unsupervised ATC speech data. On the other hand, we have surveillance data. And for each utterance, we have a list of call signs or contextual data that could be either 0, 1, or more call signs. So what we do is that we do ASR, like inference on the unsupervised data, on the non-notated data, and then we reach of this that data the lattice level, and then we add the contextual information in that lattice, and then we retrain in a semi-supervised fashion the system, and then we measure the word error rate and Callsign word error rate of this system. So the methodology is that, imagine that this is more or less, if we plot the air surveillance data in a specific let's say location for some minutes, for some seconds or things like that. This is what we see, like each square is an airplane. So imagine that we can, let's say, take a snapshot of this. So we take a snapshot of that. So for that, we need two things. We need the location and also the timestamp. And then we can know which airplanes are in a given location. And we also can infer somehow that one of these airplanes is being present, has been uttered in the utterance, in the call sign, in the part of the call sign. So So, but now the question is how we can integrate this air surveillance data in the ASR system. So our provider, or where we get this surveillance data, is from Open Sky Network, which is a provider, a partner of ATCo2 project. But this data, we have it in ICAO format. So we needed to develop in the consortium to develop a class, a function, or something to go from this compressed format to the verbalized format, or the word sequence of this. For example, this is one example, Lufthansa 189, Alpha Foxtrot, and then we need to do that. So then after that, what we do is that we have one utterance, then we know the timestamp and also the location of this utterance. This is pretty easy, like information easy available for normally if you go to a NSPS or the one who is providing the data, this is data that they normally have. So then we have the Callsign list for that specific utterance. Then we go from those ICAO formats to the verbalized format, and then we add that information during the semi-supervised training. So the question is, okay, now we have the data. We know we have it in this word sequence. So now the question is how to interface that surveillance data with the ASR system. So what we do is that we are putting that information in a WFST. We call it a bias in FST. This is two examples. Here we have, let's say we have an utterance, and then we have two call signs. Probably one of those has been uttered there. So this is an example: Ryanair 1 Romeo Kilo and Turkish 61 Heavy, and then we put it in a WFST, and then we add a discount parameter for this word sequence, and then here in the overview pipeline, you can see more or less how it works. So first, we have all this contextual data. We pass it in the WFST. Then we use a seed model. It's a CALD-based model, standard. I didn't want to show more information about the model. It's a standard CALD model, TDNF with the CNN model. And this model, we use it to transcribe the non-annotated data. We reach the lattice level, then we apply composition with this contextual WFST, and then we have the rescore lattices. Then we mix the supervised and unsupervised data, and then we train the system again. So in the next part, I would like to talk a bit about the databases, because, well, if more of you are working in this ATC area, ASR, you know that is a bit hard to get this data or annotated data. So this is what the data we have used so far. For supervised data, we have a compendium of different databases that's around 140 hours of annotated speech data. For test set, we have Mallorca and Airbus, which is also a partner of the project. And for Mallorca, we have Vienna and Prague airports test set. That's around 2 hours of test data. On the other hand, we have the unsupervised data, and also the data that is coming from, let's say, noisy channels, or what it looks like more the real scenario. When the ATCos, they are talking normally these frequency channels, or normally very noisy. So for the VHF data, as mentioned in the previous presentation by Igor, we use VHF receivers to get the unsupervised data. So far, well, at the moment of the paper, we collected 67 hours. Now we have around more than 1K hours of unsupervised data from different airports around Europe and all the world as well. And we have also two test sets. On the one hand, we have the one that the SNR level is better than, is more or less what we have in Mallorca test set, which are widely known. And on the other hand, we have LiveATC test set, which is a much more challenging test set with different SNR levels, and normally it's a very challenging test set. It's also out of domain data, which is a good estimation where if we want to deploy the system in a new environment or things like that. So this is, I just wanted to mention quickly how to collect this speech and surveillance ATC data. There is many steps, like if we have the VHF data, we have the antenna collecting this data. There are like signal to noise filtering, language ID filtering, and things like that. So maybe we just here are working with 67 hours, but that doesn't mean that was all the data that we collected at that point. It's like, it could be 3 or 4 times more, but but it was, well, filtered out. These are some results and main conclusions. I want to mention and stress out that here, the baseline that we are using for comparing the benefits of this approach is the baseline is the semi-supervised ASR model. It's not the supervised only model. So here, this way, we can evaluate how the integrating this contextual knowledge during semi-supervised learning can bring improvements in, let's say, an easy way. If we have this data, then we can add it and we can get further improvement. So for LiveATC, which is a very noisy test set, around 10 or even less dB of SNR ratio, we obtain around 17 Callsign Word Error Rate relative improvement, which is, we were expecting that because already the system is the word error rates are not as good as, for example, Vienna and Prague, which are much cleaner test data. For Vienna and Prague, we also got around 7 and 14 Callsign Word Error Rate improvement. And for Vienna was not part of the unsupervised data, while Prague was. So we can see that more improvement can be gained from that. As a general summary of what we did is that we leverage contextual knowledge during semi-supervised learning for ATC data. We developed the pipeline for this, and also we saw that the overall performance is impacted by, for example, the quality of data, also if the data is out of domain, or just pros and cons of the semi-supervised training methodology. And also, it's important to mention that the Callsign Word Error Rate gives direct insights on ASR systems on call signs. And what we see as a next step is how to integrate, how to go beyond call signs, like integrate sectors, names, airlines, and things like that, and also explore new techniques like transformer-based ASR and BPE or sentence-based lexicons. And also, I wanted to mention that in ATCo 2, we released 2 small datasets for language identification and also for English ATC speech dataset in the previous presentation was mentioned. If you are interested, we suggest you check them. And thank you.
Thank you, Juan. We have some time for questions. Are there any? If not, I have one. So how would you like to reuse the more context from the ADSB? So you mentioned that's potentially in the next step. So would you like to use the more data for the commands instruction, or for what?
We have seen that we all, for example, for the contextual data, we just know there is not just the call sign available, but we have also like altitude, speed, heading, or many things like that. So I think like if we somehow can embed that information also in the idea of boosting the ASR system, I think we can get like much more improvements in general.
Mm-hmm. Thank you.
Thanks.
So thank you very much, Juan, for your presentation.
Thanks.